problem which we need to solve, but it's more of a concept-based question. So is pi a real number? So before we even talk about pi, we need to describe what a real number is. And once we define what a real number is, then we can define whether or not pi falls under those categories. So a real number can be simply stated as any number that falls or exists on a number line. And this number line has no boundaries. So it's negative infinity and infinity. And in the middle, there's 0. Okay, so what numbers exist on this number line? Well, for one, we have the positive numbers, right? We have our counting numbers, 1, 2, 3, 4, right? So we have 1, 2, 3, 4, blah, 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 right? So let me use blue. So 1, 2, 3, 4. These numbers obviously exist on the number line, right? What about negative numbers? Those also exist on the number line, right? So we have negative 1, negative 2, negative 3, negative 4, right? Negative 1, negative 2, negative 3, negative 4, right? So we have our negative numbers and our positive numbers. But what about in between, right? What about like half, for example, right? What about, negative 3 over 2, right? These numbers also exist on our number line. And all these numbers can be categorized into different categories, I guess you can say, right? So for the numbers that are just positive, right, we can call these natural numbers, right? So they're the real numbers. We have I guess we have natural numbers. We also have what we call integers, which are positive and negative numbers, right? We also have what we call rational numbers, or numbers that can be composed of simple fractions, like 3 over 2, 1 over 2, right? So we have rational numbers. But we also have these strange numbers called irrational numbers. And these numbers cannot be composed of simple fractions, but they still do exist, right? And we know that because we look at the number line, right? And a very great example of a rational number is root 2. Root 2 is an irrational number. But another very excellent example is actually pi. So pi is always defined as the ratio of the circumference of a circle over its diameter, and equals 3.145 blah, 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 right? It's an ongoing number. The decimals continue to go. But this number actually exists on the number line, and it exists like right over here. This is where pi is, right? And there's a lot of irrational numbers which cannot be composed of simple fractions, but still do exist on the number line. So in reality, we can say that pi is a real number because it exists on a number line. The only numbers that do not exist on a number line are what we call imaginary numbers. And those are numbers that don't exist, and the subset, or the set of complex numbers, also do not exist on the real number line. So let me do one more illustration to quickly explain all of this. Okay, so let's say we have a big circle, right, or oval. And these are our real numbers, okay? These are our real numbers. So natural numbers exist in this set of real numbers, right? Of all the real numbers, there's a set of natural numbers, and these are the positive numbers, right? So natural, right? And circling the set of natural numbers, there is another set, and we call these the integers, right? So these are the integers. And the cool thing about this diagram is because it's very clear, it's very clear that all natural numbers are integers, but not all integers are natural numbers. So this diagram makes it very clear for us, which is amazing. And encapsulating the integers and the natural numbers is this other big circle called the rational numbers. Okay. So the rational numbers also exist. And just like the natural integers, all integers are rational, but not all rational numbers are integers. And finally, the rest of the space is just irrational numbers, right? So irrational numbers cannot be rational numbers. Irrational numbers cannot be irrational. So this is the only flaw of my illustration, but the other points are still valid. So going back to the question, pi is a real number, and I'll just write that down here so we don't forget why we even talked about this question. Pi is a real number. Cool. So going back to the solution here, the junior tutor uses a different reasoning to figure out that pi is a real number. They argue that since pi does not have an imaginary component, it is not a complex number or an imaginary number, it is a real number. And they give us the definition of a real number too, is any number located in a number line. And then they explain, since pi does not have an imaginary number, it has to be a real number. So yes, this solution is correct. Nice. Cool. Alright, so that ends the tutoring session for today. I hope that you guys enjoyed all those 10 questions. I hope that it really helped solidify your understanding and of quadratics, of factoring, of long division, and of real numbers. If you have any other questions, please submit them on OneClass. And I hope to see you guys again, and I wish you guys a good night. Thank you guys for attending.